Welcome back to Find Solve Explain. Today I have a BMO2 question 2 from 2013. It's a geometry problem, as you can probably tell. And so in it we have a triangle ABC. Then we have a point in that triangle. Just going to put it there, such that ACP is equal to ABP. And now we also have another point, Q, such that that is a parallelogram. I'm going to draw this slightly better. And now when we do these two lines, the question wants us to prove that CAQ is equal to BAP. Now this is essentially equivalent to asking if it asks us that whether QAB is equal to CAP. I'm just going to mark down those two angles. Now this has a really nice solution because we can use a cheeky bit of construction. So let's define a point R such that APBR is a parallelogram. So that point would be about there. Now, for the parallelograms, there are a lot of them. We have all three of those sides now being equal. Now, if we connect R and Q, we actually have a third parallelogram that has sort of created itself. And that parallelogram is RACQ. Now, we know, we now have one more parallelogram, 3 parallelograms. However, there's something more exciting about R than just the fact that there's a parallelogram. And that is that R is actually, so ARBQ is a cyclic quadrilateral. Now, as for how we know that it's a cyclic quadrilateral, so we have ABQ, and we know because of these two parallelograms that that angle is equal to ARQ. And from there, we know that ARBQ is a cyclic quadrilateral. This is quite important, so I'm going to write it down. Now, with our newly gathered information, so first of all, asking for BAQ and CAP is essentially the same thing as asking for CAQ and BAP, because I mean, you're just sort of including that bit in the center once in each of them. So if they're equal, they're always going to be, they're still equal. Now with that, we know that PAB is, so from the, first of all, from the parallelogram, RABP, it is equal to RBA. Now, from the cyclic quadrilateral, we know that RBA is equal to RQA. And then from the large parallelogram, we get that RQA is equal to QAC, which proves that, so QAC being equal to BAP proves that QAB is equal to CAP. So yeah, that's a fairly nice construction solution.